Hello! Today I'll be diving into an elegant Elixir pattern that's only possible because of OTP and the actor model that Elixir is built on. We'll explore how to implement sidecar processes tied to your current process that give you automatic process-bound temporary state that can perform work in the background, all without juggling handles or variables. And here's the beautiful part, everything is automatically cleaned up when your main process finishes or gets killed. This simply would not be possible in other language ecosystems, and it unlocks some pretty sweet developer experience possibilities. Hopefully that all sounds exciting. Let's get stuck in. So we'll start by creating a new mix project. We'll just call this processes fun, like that. We will add a supervisor tree to it. There we go. So we'll cd into it. And open Vim. So what have we got to play with here? So we've got an application, which is not starting anything at all right now. And what else we got? And then just a hello world function here. Nice. So we'll clean this module out. I'm going to write some pseudocode. So the way I came across this pattern, the way I started digging deeper into it, was when implementing an LLM call. So I'll just add just some pseudocode here for def LLM. And it will just return, it's just going to return us a string as if it had called out to an API or something. Hello world. Could have probably kept that initial function, but there we go. So in this LLM call, what I wanted to do is set up like a trace. And this would, in normal instances, you'd like get a trace back, and then once the LLM call is completed, you'd then want to like do like a trace dot end the trace or something. That comes from like the Langfuse SDK library, which I'll link in the description. That's like just the standard way using the direct API is how you would do sort of like tracing. So you could like add stuff to that trace, like stuff which has happened in this LLM call. But I was thinking this is really annoying, especially when you've got like this part might be like there might be a bunch of functions that come together to generate that. There's like stuff which can happen with like function calls to build that chain. Yeah, you don't want to be hanging on to this trace and then like passing it around. That's really annoying and frustrating. So first off, we'll just go and actually implement that trace module. That's probably a good place to start. Say trace.ex. And again, this is like, I'm happy to keep this as just pseudocode. I don't really care what any of this does. So we'll just say new just returns I guess we could make this into a struct. And it has like an ID. How you do it? No, it's like a list, right? Like that. Can't remember. Let's see how we do. ID make. There we go. And an end function. Oh, I can't call it end. Of course I can't. We'll put end trace. How about that? We'll take a trace, and then we'll do some network request. Yeah, like doesn't really matter what this does. Okay, so that's a trace. It's just it's a structure that you start it, and then you can at certain points you could add stuff to it. Not going to add that here, but the most important thing is that it then ends, and then the ending of the trace, it gets fired off to your observability provider. This would probably be done with OpenTelemetry if possible. But if you're manually having to do this, that's how I came across it. But it's kind of like the pattern that I'm most interested in here, what I want to show off the most. We have our trace. Let's close that. And let's just make sure that we've got trace in scope by an alias. There we go. It wasn't called end anymore, it's called end trace. Okay, so then we should call this response equals hello world, and then we'll just actually return the response. Okay. And let's just abstract that quickly and call that call LLM. There we go. Okay, so that's a bit more realistic as to what's happening, I guess. This would undoubtedly be like a lang chain being set up with like the model and, the function calls and all that sort of stuff. Not that interesting for the specific thing we're trying to get to here, which is processes. I guess another thing we'd want in this end trace actually is like the response. Like, how do we know what the response is? So I'll just make this actually a two-arity function where you pass that in. Let's hop over there. So you get like the trace and the response from the LLM. Makes a bit more sense then. Yeah, so we need that state passed in. So just to show you why actually having this trace handle here, this variable that refers to the trace, is actually really annoying. In this call LLM function, so that like doesn't take any arguments at all. It should just be its own isolated thing. I can just go and call that LLM. In here, I've got like a stubbed LLM chain. Imagine this is a lang chain thing, but it doesn't actually matter for our purposes. I just want to show off that like you might need to delve a bit deeper into it. So in LangChain, you have like an add tools, and then on that tool, in here, you check the user's name. You can imagine you might want to add some more trace information. You might want to add like a specific span to that trace, saying like, I'm going to call I've gone off to call this function call has happened. This is how long it's taken. These are the arguments that were provided by the LLM, all of that good stuff. But we don't have access to trace. Like, where's trace coming from? The only way to get trace is going to go back up. That needs an argument, which means we need to go up to here. That's going to need an argument. Like it really just frustrates our DX by requiring the trace to need to be passed through. It feels like prop drilling or something. What's wrong here? Get name. Oh, okay, cool. I'll just stop that out with get name can always return Connor. It's only me that's ever going to use this piece of code, so that's fine. I didn't add span or end span. Okay, let's just stub those as well. You get the idea. There's some stuff that mutate this trace until eventually, when the trace ends, all of that state that it's collected up is then sent off to your LLM observability provider. Okay, so that works. It's like pretty readable. It's just annoying, you know? Like, and any language could do this. You just need to, you're making a variable up somewhere and you need to just keep track of it somehow. Now we can go on to the interesting part where we can use OTP. We can use processes, and, you know, this LLM call, whenever this is invoked, it's going to be invoked in one process, and it will stay in that process until it completes. So you could imagine that if you wanted to do like a ton of different LLM calls for different users and things, each of those would be, in this application, implemented as its own process. You'd do it in a task, or just doesn't really matter. Just some kind of OTP process is going off, hitting the LLM and coming back. So like you're safe in your little process bubble, but you need that like trace to also be linked to that process, which means that this opens up a possibility. We could just do a new temporary process tied to this one. So let's look at how we would do that. So I'm just going to make a new module, and we'll just call this like tracer. So this tracer is going to be a GenServer, and it's going to be a restart temporary. This is going to mean that once it ends, we're not going to attempt to restart it. We only care about it that one time. So that's pretty useful. We're going to implement the init. It's going to hold on to a trace, right? So we've got the trace, which we already implemented as trace of new. So when this GenServer starts, it will go and create that trace for us. Oh yeah, for good measure, I'll just add a cheeky little import true there. So this is a GenServer which just holds that state. That's it. So we'll need a handler for when the process needs to be ended. So we can say end trace. It's got that state which has the trace on it. And then we can just call trace.end trace state.trace. Okay. Actually, it won't be okay. That will be our trigger to stop this process and say goodbye, game over. So that's a normal stop, and then we return the state as well. So we'll have in this message, we'll have that response, because that needs to be our second argument. Okay, nice. So that means that we can start this GenServer, holds the trace, and then we can call with a special message. We can ping this GenServer with end trace in the response, and then that will close the state down and send it off. So let's add some helpers to help us interact with this, rather than us needing to use those low-level GenServer functions. So we'll say start trace, is going to. So this is for starting a linked GenServer. This module, the initial args actually are nothing. Do like an empty list there, empty keyword list, and any options. We'll leave the options for now, but we'll come back to it. So the thing with this is that's going to give us back, to show it in this little pop out here. I'm sure it gives us back OK in a PID. So if we just hop back to our processes fun, we can see that if we change this, we stop doing the tracing ourselves, and instead we go for tracer. We say tracer.start trace. That actually is going to need, it just gives us OK and PID, which, you know, it's just moved it into a process, but we still need to hold on to that PID. You know, we're gonna have to pass that PID around to know, like, who is it we're gonna call to go and access that state? Who is it that that holds the trace for us? So that's just basically the same as having the variable. So that's not what we want. We need to upgrade this slightly, and we can do that with registries. So with GenServers, you have the possibility of giving it a specific name. So I could give this the name like random, and then you can always reference that GenServer via its name random. So that's fine, except from we need this to be dynamic. We need the name to be linked to the actual process that called it. So to do that, we need to, first off, set up a registry. That's actually a very important step, which I've not done yet. To do that is very simple. We just, in the children of our application, we just do registry, which is a built-in Elixir thing. And then we need to give it we can say the keys are going to be unique, and we need to give it a name. And the name for this will be, we'll call it processes fun registry. It's like sort of my app registry. This is kind of quite similar to how you set up like a task supervisor or something. You just need to like say, I'm making one of these, and this is its name. So the application supervision tree is going to add a registry to it, which allows us to store the keys to the various processes that we decide to name there. So we can set that name up. We can say name is, we'll just call it an empty tuple for now. And that's where we're going to be passing it in. So some very specific tuple magic you need to do here, which just is like, you can read it from the documentation of Elixir, but it's just, you need to say that instead of me giving you a name, I would like you to go via a registry and go in and access it as using this like key value pair. So you would give, when you start the GenServer, you're sort of saying like, I'm starting it with this key, and then it stores it in the key value store that is the registry, which is then accessible via that name later. So you can say like, I'm storing it under this ID, I'm getting it back out, that kind of thing. So to do that, we say via, and it's going to be via the main Elixir registry. And then that takes its own argument, which is the name of our registry. Processes fun registry. That's what we named it in the application supervisor. And then this is then the key that we're going to be using to access it via. So we'll say we'll call it this module, because that's like so it's a key to a tracer. So we might as well name it the module. And then we're going to say self, the PID of the current process that is calling this. So we're going to be calling start trace from our LLM process. It's going to go to the registry and say, with my PID, make me a tracer, and then that's going to be the name of the GenServer which is tied to it. This actually means that we no longer need. We could just check that this is okay, and that we don't care about the PID anymore, because we can just reconstruct this at any given point from that process, because it's going to be tied to using the PID that it currently is at. This argument here could actually be anything. We could use the trace ID if we already had that, or you can do whatever you want with it. It's just that PIDs are pretty great as keys, because it's like that's not going to change in the entire lifetime of the process that you're currently in. But you could use other things. So we'll start up our Sidecar GenServer linked to the current process. So we should implement an end trace as well, which is going to do some pretty similar stuff. In that it's just going to grab the name and then do a GenServer cast to the name. And our specific message shape was a tuple with end trace and the response. Where does the response come from? We'll have to have that as an argument. So we can refactor our processes fun to instead be, we don't care what the response is from that. We've got, we start the trace, don't need to pass through the trace, and then we can just end the trace with a response. Call LLM now doesn't take a trace. Let's get rid of that. Just get rid of all of that. We didn't implement add span. I guess this should actually be tracer.addSpan. We don't have a trace to do the tracer thing with. Let's just go and implement that so it doesn't shout at us. I don't really care too much about this. This would leave this up to you to implement fully, but you're kind of getting the idea, you know, because this span could then be just kept solely in state. The handle for it doesn't matter. Like if it's only one span at a time, you know, you could add a span to like to a list, pop that off, and then like end it, and then as you roll back up, because you can have like multiple spans in an overall trace. Implementation details not entirely important here. The key thing is that we're off the main process, and we don't need to hold on to anything in that process. So it keeps it quite dumb. It keeps it quite like separate. And spans, we don't even need to pass the span there at all. We can just say it's not trace, it's Elixir. Yeah, so we could just like add a span, end the span. Like maybe we want to, you know, give it the results or something like that. That's all very easily implementable. Yeah, end trace does not exist. Oh, it's because it's tracer, not trace. Yep, there we go. So the only thing left to implement in the tracer itself is do another input true. Terminate, callback. Don't really care about the reason. And the state. And in this instance, we would also want to end. We'll just do nil for the response there. That's fine. And then just return OK. So that's like if the parent process, the LLM call just completely fails, it like breaks or whatever, we can still, in our sidecar process over here that holds that trace, we can still go off and ping that off and send the trace before we end up actually killing the process entirely, which is really nice. And that means there's not like processes hanging around, but it does mean that we can do the cleanup before, you know, in the case of like a catastrophic error. That also wouldn't be possible if we were just holding on to those variables and then in the state of the GenServer, the trace is being held. Like, we'd have to handle that actually at the GenServer level, but instead this is generic enough that it could be added to any process, and then if that process goes down, we would still fire off that trace, which is pretty damn nice. So yeah, just pretty random one, but I thought it would be worth just diving into because yeah, that can completely like revolutionize how you structure APIs, which are sort of like might be a little bit awkward, might be like, you know, need to be injected in a few different places. Like, where does the actual state for that live if you need to be collecting all this stuff to then finally go off and do something? And yeah, just having processes tied to each other in that way, it's actually just really easy in Elixir, using registries. So yeah, I hope this is like thought-provoking, and allows you to think through some other patterns that you might come across that this would be a good fit for. But yeah, I encourage you to experiment, go away and play with it. Enjoy all of the goodness that Elixir has to give you. And there we have it. That's everything. Thank you so much for watching, and I'll see you in the next one.